So we are going to start today physics, and today we're going to start the first chapter of the class 12, first chapter, electrostatics. Now, that electrostatics is a special subject. You can see electrostatics in electricity related something, electricity, and statics means which is a stagnant, which is not moving. Money whenever the charges are fixed at a certain position, which is not moving, that subject is electrostatics. Just we are going to discuss that. Now see, so in the electrostatics, we are going to take some stagnant fixed charge. Let's think charge Q is existing there. It is a positive charge. This is positive charge. So property of this charge is that in the environment of that charge, it creates a field. What kind of field? That's called electric field. We will discuss what the electric field is. So now, whenever I'm just going to take this charge, okay, so suppose I'm just going to take this a positive charge. So a most important theorem, law is connected with it, and it's called Coulomb's law. That's called Coulomb's. Actually, you see, this law is very much important for our board exams also, as well as for the competitive exam, because we are just going to do the crash course. For this crash course, we have to complete the important things and one of the important things is Coulomb's law. Let us think that I'm just going to see that a charge is existing here. If this is the Q, and another charge I placed it here, that is also positive. That let's say the Q dashed. These two charges are placed it here. Now, what will happen here? We can see that these two positive charges will again going to repel each other. These two positive charges are going to repel each other. This is the property: positive repulsion and negative positive attraction. Okay? So let us think if this is, I'm just going to see this charge and this charge are going to repel each other with a certain force. They are going to repel each other with a certain force. If this is positive and if this is negative, we can see that this positive charge is going to attract this negative charge. This is a simple thing. Positive repulsion, positive attraction. So now Coulomb's law is a law which is going to determine what amount of force these two charges are going to apply each other. That is the Coulomb's force. So now from the point of view of the Coulomb's law, just we are going to just shift. So according to Coulomb's law, the force, interacting force between these two charges, the F, that is Coulomb's force, is directly proportional to Q dashed. You can tell us how it is coming. How it's coming? No, it is experimental fact. Experimentally done. Coulomb was a scientist. He's done the experiment. He has seen that the force of interaction, either attractive, either repulsive, that force is directly proportional to Q dashed. Okay. And experimentally, he has seen that this force is directly proportional to, if the distance between these two charges is r, this force is dependent upon r square. The force is inversely proportional to 1 by r square. Okay. So now what we can do from here, just if I just combine these two, I can get Q dashed divided by r square. So now up to this point, we can write some proportionality constant Q dashed divided by r square. Now you see this force, which is going to depend upon the magnitude of the two charges. You can observe from here Q dash, they are the magnitude of the charges. R is the distance between the two charges. Now finally this K, this proportionality constant, it is also dependent upon the medium where the charges are situated. The medium, just like see, if I'm just going to place these two charges in air, I can place these two charges in the air. I can place in these two charges in some separate environment like this, in some chemical. I can place these two charges in some special gas. I can shift the material, the medium where the charges are placed. Naturally, this constant is dependent upon the medium. Let us think this K. This K, when I am just going to place these two charges in the vacuum, this value of this K is going to become 1 by 4 pi epsilon naught. So now ultimately the value of the F is going to become 1 by 4 pi epsilon naught Q dash divided by R square. So you can see this is for vacuum. What is this thing? 4 pi is a constant number, no? 4 is a constant number, pi is a constant number. So what is the special? This one, epsilon naught. Epsilon naught is called permittivity of vacuum. It is a special thing. It is called permittivity. Okay. So what is this thing? What is this permittivity? Actually, the permittivity, just from the name, you can see the permittivity means that medium, suppose here vacuum, that medium is permitting some amount of force. Suppose instead of vacuum, I can place these two charges in some separate places. I can do. So instead of epsilon naught, it is going to become some another value, permittivity in that medium. Isn't it? Understanding my point? Huh? So naturally, the permittivity is going to vary from medium to medium. Different medium have different permittivity. Okay, very good. So now let us think just like see. Expression, the magnitude of the force is equal to 1 by 4 pi epsilon naught q dash divided by r square is the force, interacting force between the two charges, either attractive, either repulsive. The magnitude of the force is not going to change. And this epsilon naught is the permittivity of the vacuum. If I'm just going to think that I have changed that medium, then, and the medium's permittivity is epsilon, and the medium's permittivity is epsilon, then the force in a separate medium is going to become 1 by 4 pi epsilon q dash divided by r square. The same two charges, the same distance existing between them, but I have changed this medium. Then the permittivity has changed. Okay. So naturally the force is going to change. Let us think that the force is going to become F dash. Naturally, it is we have to understand that upon the three factors, the magnitude of the charge, the distance between the two charges, and the medium is the force is going to depend upon. Okay, okay, very good. So now see, from here, from this expression, we have to take another definition. The CBSE or ICSE, just ISE question can come from here like this. Epsilon means permittivity of a particular medium divided by epsilon naught, permittivity of vacuum. I'm just going to write like this one. It is epsilon r. It is called a relative permittivity. What I'm just going to tell is called relative permittivity. Epsilon r, but sometimes we call electric constant. We sometimes call what is called so epsilon r has two names: relative permittivity or dielectric constant. So naturally you can observe that epsilon r is what? It's a pure number because it is the ratio of the two similar quantities. It is the ratio of epsilon and epsilon naught. They are similar quantities. The ratio, it is going a pure number, isn't it? So it is a special property of that special medium. So now naturally, the epsilon I can write like this way, epsilon r into epsilon naught, like this way we can write. The permittivity of a medium is that epsilon naught into relative permittivity of that medium is equal to permittivity of that special medium. Clear? I think so. So whenever the relative permittivity is going to change, the value of the force is going to change. Okay. So up to this point, I think everyone clear. So one thing you have to remember that in this situation, whenever I'm going to talk about the Coulomb's law, we have considered the charged particles as point charge particles. Simple point charge. Point means what? Just a point means what? Just like the dimension is infinitely small. Point. 2 points, just like. So naturally, it is not possible that exactly at a very small dimensional region I'm going to place some charge. So it can have some dimension, like this spherical shape. I can have. It is going to have some charge existing distributed over these two spherical shaped charged object. So what should be the distance? Actually, in this situation, we have to take the center of charge. Just like see, in the class 11, we have done the center of mass. The mass is scattered in a certain region, so we can calculate the center of mass. You know, I think so. So here also, if scattered charge is distributed in a certain region, we have to take the center of charge. There is some formula is there. But suppose if I take a sphere, a charged sphere existing uniformly charge distributed, then we are going to take the center of the sphere as my center of the charge. Therefore, the distance r, what should be the distance r? Distance from center to center. That will be the r. Understanding my point? I think you're understanding. Okay. So from center of the charge to the center of the charge, this distance we are going to put in this formula, in the Coulomb's law. Okay. And the interacting force, either attractive, either repulsive, doesn't matter. This interacting force is going to act along this straight line from the center of the charge to the center of the charge. If it is attractive, along the straight line, these two forces are going to act. If it is a repulsive, along this straight line, this is going to act. Children, I think you are understanding my point. So this force cannot become inclined like this way. No, it is not possible. This force, this interacting force is not, it is not possible that this force is going to become inclined with this line. Which line? The joining line between the center of the charges. It is not possible. Any inclination is not possible. By the joining the 2 points, the force is going to act along this straight line. Okay, very good. So this is the basic definition of the electrostatics we have started, and we have started the how to calculate the magnitude of the Coulomb's force. We have just discussed the Coulomb's law. And now, from this Coulomb's law, we have to understand, just in the starting of this my lecture, I told that whenever I place a charge, it creates the environment. That environment is what? That is electric field. Surrounding of the charge, electric field exists. Isn't it? Electric field. So we have to find that what is exactly the value of the electric field. Okay, let us think, just like see what is the exact value of the electric field. So definition of the electric field, or we can tell that electric field intensity. Electric field intensity. So what is this thing actually? Let us think that we have placed a charge here, and at a certain distance, let us say at a distance r, we have placed a unit positive charge. Actually, charge we measure by unit coulomb. 1 coulomb, 2 coulomb, 3 coulomb, just like this way, in that manner, coulomb. According to the scientist's name, we have given the unit of the charge. So we have just placed the 1 coulomb. So what is the force, interacting force? We can see that the force is going to become 1 by 4 pi epsilon naught. If I am going to take it in the vacuum, Q into 1 divided by r square, but simply 1 by 4 pi epsilon naught Q by R square. So due to this positive charge at this point, this 1 coulomb, see 1 coulomb, 1 C 1 coulomb. This means this 1 coulomb charge is going to experience some force. This value is 1 by 4 pi epsilon naught Q by R square if the environment, if the medium is vacuum. Okay. So now let us think that definition of the electric field is what? I can tell this is the electric field intensity. So what is the definition of the electric field by electric field intensity? What I can tell? Just to tell that force experienced by a 1 coulomb charge, positive charge at a certain position. The force experienced by a unit positive charge, 1 coulomb charge at a certain position is called the electric field intensity at that point. Electric field or electric field intensity. Every time we are not going to utter the same thing, electric field intensity, electric field intensity. No, we are going to tell electric field. Okay. So what is the value of the electric field due to this plus Q? At distance are 1 by 4 pi epsilon naught Q by R square. Now see, yes, just like see, instead of this 1 coulomb, we are just going to take it here, another charge Q1. That is also positive. Doesn't matter. Positive, negative doesn't matter. So what should be the force? This force is according to Coulomb's law 1 by 4 pi epsilon naught Q1 divided by R square. Okay. Very nice. So now this Q1 is going to experience this much of force. Q1 is going to experience what amount of force? F. So what should be the 1 coulomb charge is going to experience? F by Q1 according to our definition of the electric field intensity. The electric field intensity is what? Force by charge. We write this is E. F by Q1 is equal to E. So therefore 1 by Q1 into, we have got the value of the F. We can put it here 1 by 4 pi epsilon naught Q1 divided by R square. So Q1 is getting cancelled. So what the result is going to come? 1 by 4 pi epsilon naught Q by R square. We can write this is my expression of the electric field due to this charge at a distance R. I think the electric field by electric field expression of the electric field intensity, I think it is clear. Okay, fine. So the expression of the force we can write charge multiplied electric field. Bas. Just like see, charge multiplied electric field, there's a force. I think it is clear. No problem. Okay. Okay, fine. So now you can see that from this expression, force is a vector quantity. Charge is a scalar quantity. I cannot just determine any direction. So the 1 coulomb charge is placed here. I cannot tell that this charge is going to act in a certain direction. No, it is not possible. So now what the thing is there, if I just want to balance the vector equation, we have to put a vector sign on the electric field. So electric field is a vector quantity. Okay, so charge multiplied by the electric field, I am going to get the force. Charge multiplied electric field, I am going to get the force, expression of the force. Okay, fine. Now, see, we are, just I'm going to change the page here. So from here, different questions can come, either in the board exams, CBSE, ISC, whatever, or either in the competitive exams also. Okay, let's see, just we are going to take some examples of the electric field, okay? And some examples of the Coulomb's law also. Okay, fine. Very good. Let us think just like, see, I am going to have a charge Q. I'm going to have a charge Q, and this two having a distance between them Q, Q. Both are going to take positive. and the distance I'm going to take is a 2L. Total 2L. I'm just going to take a middle point. I have taken a middle point just like this one. So the length will be, this one will be L, this one will be L. Now, from the middle point, we are taking a point like this one. Just let us think this distance x. Which distance? This distance is x. And from here to here, 2L. From the middle point, I'm just taking the x. Now, see, just like see, a charged particle having mass m, and the charge again, I'm going to take the plus. Sorry. I'm going to take a charge minus q and mass m. I have placed it here. Okay. So you have to find the what should be the force this particle is going to experience. What is the net force? Okay. So now see. Positive charge and this one is negative charge, this positive and negative attraction is going to occur because we have to find the force on this negative charge. Simple thing. Okay, so this plus q is going to attract this one. Naturally, this plus q is going to attract this one also in this direction. Attractive force. This is not a repulsive force. If this is a positive, they were going to repel each other, but this is a negative, it is going to get attracted. So now, see, this line which is having a length 2L, I am going to take another line which is parallel to the 2L. Parallel to the 2L. Okay. This line parallel. So if I am just going to think that this is theta, alternate angle, theta, simple geometry. This is theta, alternate theta, like see. Now, force 1, I am going to take the interacting force between this charge negative and this positive. Let us think this is F1. F1. What should be the value of the F1? I can see F1 is equal to, if all the charges are situated in a vacuum, so we can write like this way, 1 by 4 pi epsilon naught. Magnitude will be Q into Q divided by, what is the distance between them? This length is x, this length is L. Naturally, you can see this angle is 90 degree, perpendicular bisector, I can see. So, the length of this line is equal to root over x square plus L square, the whole square of that thing. Okay. So, ultimately, we can see that x square plus L square. Okay. This force F1 is going to act like this way. Now, F1 I can write 1 by 4 pi epsilon naught q square by x square plus L square. Just similarly, if I'm going to take this one F2, this is F2. So this negative charge is going to get attracted by this positive charge. This way, attraction. Attraction is going on. So this F2, the magnitude is going to become same value, 1 by 4 pi epsilon naught q square by x square plus L square. Okay. Now see, if you can see 1 by 4 pi epsilon naught q square by x square plus L square, 1 by 4 pi epsilon naught q square by x square, both them, these two, the F1 and F2, magnitude is the same. Naturally, if I take the component of F1 in this direction, F1 having a component F1 cos theta, you can see symmetry. This is theta geometrically. So naturally, this is F2 cos theta. Since I can see that this theta symmetrically each and every one is same, so like F1 cos theta, F2 cos theta is getting cancelled out. So the cos components are cancelling out. So what is the thing? The sine components are cancelling? No, the sine components are not cancelling. So finally, what should be the force? F1 having component in this direction, F2 having component in this direction. Therefore, we can write F net force on this charge, negative charge, which is going to act this direction. It should be F1 sine theta plus F2 sine theta. Okay. So what is the thing? F1 magnitude, you know, this is the thing. 1 by 4 pi epsilon naught q square x square plus L square into sine theta. Similarly, F2 is having the same magnitude. 1 by 4 pi epsilon naught q square by x square plus L square sine theta. Therefore, we can write 2 into 1 by 4 pi epsilon naught q square by x square plus L square into what should be the value of the sine theta? You can see from here, this is the right angle triangle like this way. Sine theta is perpendicular, this one is perpendicular, one is perpendicular by hypotenuse. What is the perpendicular? This is a x. We have already told. What is the hypotenuse? Root over x square plus L square. So we are going to put this one. Sine theta mane x by root over of x square plus L square. I think everyone is getting my point. Therefore, now 2 divided by 4 pi epsilon naught q square niche x square plus L square into root over x square plus L square. What is the result? X square plus L square having a power 1. Root over x square plus L square having a power half. Tale total power 1 plus half. 1 plus half mane 3 by 2. Tale x square plus L square whole to the power 3 by 2 into x. So this is the final expression of the force which is going to act this way. This charge, the negative charge is going to experience a force like this way in this direction. The magnitude is this much. Okay. Now see, question once in a WBJE and some they have asked that like this way, just like if this x, this much x is very less than L. L is very bigger than x. If this condition, initial condition, naturally in this expression, what we can do from here? L square x square, x is very less than L, so we can just omit and neglect. We can neglect this x. So finally, for this condition, what will be the force? That force, when this x is very small with respect to L, we can write like this way: 2 by 4 pi epsilon naught q square x. Niche x is 0 in comparison to L. So L square whole to the power 3 by 2. L square whole to the power 3 by 2. So we can write like this way: 2 by 4 pi epsilon naught q square L cube into x. That should be the force. You can see L square whole to the power 3 by 2 mane L cube. So 2 by 4 pi epsilon naught q square by L cube into x. You can see in this situation, this one, the charge is fixed. I'm not going to change the charge. The length is fixed, L. 2 by 4 pi epsilon, that is also constant. So what is variable? X is going to vary. So now if this charge is released from here, by this force, still the x is very small. By this force, it is going to get attracted towards the central point. It is going to come back this point, again this will go, again it will be returned back. So here also, from this condition also, we can tell that. So it is going to a oscillatory motion. It is going to come back, again it is going, because whenever it is coming to this position, it is just gathering some velocity, kinetic energy. So it will not stop here. It will cross this line, but still attraction is possible. Attraction is going on by these two charges. So again it will stop, again they will return back. So it will be oscillatory motion, but it is not a SHM. But when this condition is satisfied, we can see that the condition of the SHM is Condition of the SHM. So what is the condition of the SHM? The particle, this negative particle is going to oscillate in the simple harmonic motion when L is very, very greater than X. In that situation, we can say that F proportional to X. F proportional to X. Actually, the proportionality constant is existing here. Actually, since it is a restoring force, the property of the SHM is equal to F is equal to minus Kx. That we can put it here. F is equal to minus Kx, we can put it here. So we can put the negative sign also here. Since it is a restoring force, we can just write negative minus. Why? Why minus? Restoring. This is bringing back. Okay. And it is proportional to X. Therefore, if the mass of this charged particle is M, we can tell that the time period of the oscillation 2 pi root M by K. What is the value of the K? Mass is the mass, it is known. What should be the value of the K? This is a total constant. This part, 2 by 4 pi epsilon naught Q square by L cube. So therefore, the time period of the oscillation of this negatively charged particle, whenever released at this position, when this X is small, very small, we can write the time period for the simple harmonic motion M by 2 by 4 pi epsilon naught Q square by L cube. The time period of the oscillation of this particle, negatively charged particle, if I'm just going to press it. Okay, this kind of question can come in the JEE or any type of competitive exams. Okay, fine, very good. Okay, now just go to the another topic. I'm going to change the page. Let us sing. Let us sing. Just like previous one. Like previous one. I'm going to have the two charges are there, same value. Okay. Is it equilibrium? This system is in equilibrium. No, not possible. Why? Why not possible? Because this one, this positive is repelling this one, this positive is repelling this one. So by the repulsion, they will go away. So they are not equilibrium. Okay. So we have to create a situation so that it will become equilibrium condition. So it is told that at the middle point, let us think distance is 2L. At the middle position, we are going to place a charge Q. We are going to place a charge Q so that the system is going to become in equilibrium. Okay. So how it is possible? You can see that this charge, if this charge is positive, let us think, just imagine this positive charge. So what will happen? Initially, this positive was getting this positive is repelling this one. So if it is positive, again it will repel. So is there any possibility that it will become in equilibrium? Because equilibrium মানে কি? Equilibrium মানে কি বল? কি বুঝবে তোমরা? Equilibrium মানে net force টাকে zero করতে হবে, তাই না? So naturally, in this situation, we are going to see that we have to make the force on this Q 0. So we have to place a negative charge here. The magnitude of the negative charge that we are going to find. Okay. Similarly, this negative charge is attracting this one also, this direction. This negative charge attracting, and this positive charge repelling. So these two forces are cancelling each other, isn't it? So that's why this coming into the equilibrium position. In a similar manner, this is coming into the equilibrium position. Understanding my point or no? So similarly, if I just going to consider this minus Q also, this minus Q is going to get attracted this plus Q. And this minus Q is going to get attracted by this plus Q, this one. So they are equal and opposite. So this is also in equilibrium. So now the system has come to a equilibrium situation. I think you are understanding my point. So we have to find the value of this capital minus Q in terms of this Q and the distance. Okay, let's think just like what is the repulsive force Q and Q. 1 by 4 pi epsilon naught q into q square divided by, what is the distance? 2L whole square. Repulsive. What should be the attractive force? Magnitudically same. They are magnitudically same. 1 by 4 pi epsilon naught. I'm just going to take this like magnitude, nothing else. Q. You will tell that, sir, why you are not going to put minus Q? No, it is not necessary here. Just because we're just going to because just this attraction, this repulsion, they are cancelling each other. So we're just going to take the magnitudes. Okay. So this Q into Q divided by what's the distance? L square. Take. So expression, you can see the 4 pi epsilon naught, 4 pi, both sides cancelling out. So the result is going to come Q square by 4. L square is equal to Q by L square. L square ডান দিক বাঁ দিক কেটে গেল, ঠিক আছে? তাহলে কত রেজাল্ট আসছে? এখানকার একটা কিউ এখানে একটা কিউ এর সাথে ক্যান্সেল হচ্ছে, তাহলে Q by 4, ঠিক আছে, ইকুয়াল টু Q। এখান থেকে এটা কি পজিটিভ না নেগেটিভ? পজিটিভ না নেগেটিভ? নেগেটিভ লিখতে হবে। देयरफॉर आंसर কি লিখবো? হ্যাঁ, q is equal to minus q by 4। এখন বুঝতে পারছো কি? এটা आंसर লেখার সময় মাইনাস করে লিখতে হবে। এটা তো ম্যাগনিটিউডিক্যালি লিখলাম। হ্যাঁ, তুমি বলতে পারো স্যার নেট ফোর্সটা দেখাতে পারতাম, এটাকে প্লাস করে এটাকে নেগে এদিকে নিয়ে গিয়ে, বাট ইটস নট নেসেসারি, জাস্ট ফলো দিস প্রসেস। তাহলে q is equal to minus q by 4। And in this situation, it will come in equilibrium.